Welcome to this module, and here today we will see what exactly as a differential amplifier. So, we have seen the op amp as an inverting, we have seen op amp as a non-inverting, and we have seen op amp as a summing amplifier. Now, let us see how the operational amplifier can be used as a differential amplifier. All right. So, if you come back to the screen. So, if I have a op amp in the following configuration, in the following schematic or following circuit, then what I see is I am applying input to the inverting as well as non-inverting amplifier, correct. Applying input to the inverting as well as non-inverting terminal of the amplifier, inverting as well as non-inverting terminal of the amplifier. I have values R1, R2, right. In this particular configuration, how can I find my output voltage VO? First case is how first I have to find the output voltage VO, the relation between the R2, R1, V1, V2 with respect to VO. Okay. So, you see these points, one is V minus, another one is V plus, one is V minus, another one is V plus. Now, what can I see? V minus equals to V plus. How? Because current into the op amp is 0 or because of the virtual ground concept, right. V 1 equal to V 2 or V minus equals to V minus V plus. So, I would be, so this one, okay. First we are considering this value which is I 1, then we will consider the value which is right over here I 1, okay. So, this value is nothing but what will be V 1 minus V minus. So, V 1 minus V minus divide by R 1, correct, and if I consider this value then it will be nothing but V minus, right, because here you can see here, then you have to see here. So, it will be V minus minus VO by R 2 minus VO by R 2. So, what is my V plus? My V plus here. Now, if I want to measure this value V plus, right, what will V plus? V plus will be, so you see here V plus, you have to consider this ground, you have voltage here. So, this is like a potential divider. So, V plus will be R 2 divided by R 1 plus R 2 into V 2, correct, because you see here V 2 is V and here is a ground. So, it looks like we are measuring, we have V 2, we have R 1, we have R 2 and we are measuring the V plus, correct. So, V plus would be nothing but R 2 by R 1 plus R 2, V plus would be nothing but R 2 divided by R 1 plus R 2 into V 2, right. Now, I know that V plus, right, because V minus equals to V plus. So, I will also put my value I 1 equals to this both values. So, V 1 minus V minus by R 1 equals to V plus minus V o by R 2, correct. This is the value. Now, if I substitute the value of V plus, if I substitute the value of V plus in this equation, right, what will I write? V 1 minus this value divided by R 1 equals to R 2 divided by this whole value, again we are substituting here in this place, right. So, if I solve further, what will I have? When I solve the complete equation, I will find that my VO equals to minus R 2 by R 1 V 1 plus R 2 by R 1 plus R 2 into 1 plus R 2 by R 1 into V 2. Or further I solve it, then my voltage output voltage will be nothing but R 2 by R 1 into V 2 minus V 1, correct. When you solve it further, you will get nothing but R 2 by R 1 into V 2 minus V 1. So, what is it doing? It is the differential amplifier. It is amplifying the difference of voltage at the output, right. And what is amplification factor? Amplification is done by values of R 1 and R 2. Amplification is done by substituting the values of or selecting the values of R 1 and R 2. What are R 1 and R 2? R 1 and R 2 are my feedback resistors. R 1 and R 2 are nothing but my feedback resistors. Okay. You got it? So, this is how my differential amplifier would work, that whenever I apply a voltage at both the terminals, voltage V1 and here V2 at the another terminal, my output voltage will be nothing but difference of the voltage, right, difference of the voltage into R2 by R1. This is the formula that I have to remember, and this will be my differential amplifier. This will be my differential amplifier. Okay. So, let us solve an example. Let us solve an example. So, for the differential amplifier configuration shown here, it is given that R1 equals to R3 equals to 10 kilo ohm. So, this is 10, this is 10, R2 equals to Rf equals to 20, this is 20, this is 20. Solve for the output voltage, you have to find VO, right, the input voltage V1 terminal and input resistance to V1 terminal for 3 cases, V1 equals to 0 and V1 equals to minus Vi2, right. So, let us see one by one. Now, because Rf by R3 equals to R2 by R1, the output voltage is given by, it is very easy, right, VO equals to Rf by R3 into this one Vi1 minus Vi2, right. If I substitute the value 20 divided by 10 equals to 2. So, 2 times Vi1 minus Vi2. So, as Rf equals to 20 kilo ohm and R3 equals to 10 kilo ohm, input resistance to terminals Vi1 and Vi2 varies as shown here, you can see here, right. So, what will happen, therefore, input resistance to Vi terminal 1 is nothing but R1 plus R2, right. If you see this circuit, what we will find that the input resistance to terminal Vi1 will be nothing but R1 plus R2, right. What is R1? R1 is 10, R2 is 20. So, it is 30 kilo ohm. Input resistance to Vi2 when Vi1 equals to minus Vi2 will be, if we apply the Kirchhoff voltage law, then you will find that Vi2 plus Vi2 into R2 divided by R1 plus R2 divided by R2 equals to R3, right. If you see this circuit, you have to see this circuit, you will find this how we are solving. Also Vi2, so when you further solve it, what do you get? Vi2 by I2 equals to this particular value. So, therefore, the input resistance into terminal 2 after substituting the value. So, if I this is nothing but my input resistance of the terminal 2, right, Vi2 by I2 is nothing but input resistance to the terminal 2, right, whatever the input resistance is. So, substitute, if we substitute the values, what will I have? 6 kilo ohm, I have value of 6 kilo ohm, right. So, this is how we can solve the problem for the differential amplifier. Now, understand that I am little bit getting faster in solving the things, I am little bit speeding up my lectures. The reason is that you have to also try to understand how to go in a frequency with the teacher, alright. This is another skill that as a student, as a listener, we should develop, that if the speed is increased, our capability of understanding the problem should also increase, and that can increase only when we are clear with the earlier lectures, alright. So, when I talk suddenly about virtual ground, you do not have to go back and see what is virtual ground, right, because you have already seen and you have already know what exactly virtual ground is. Similarly, when I talk about inverting non-inverting amplifier, immediately you should be able to see, okay, that was the case, there is an equation. Now, differential amplifier VO is nothing but minus Rf by R1 into V2 minus V1, or Rf by R1 into V2 minus V1. Now, if I talk about solving the differential amplifier, this is how you can solve the differential amplifier. So, we have taken 2 problems in which we have solved the differential amplifier, right. Now, if I want to show you a problem where there is a current to voltage converter. So, if you come on the next screen, there is a current to voltage converter. What you see here is the first circuit, right, and here if I want to understand, then what is it? If would be equals to I1, right. So, another way is V and then V plus equals to V minus equals to 0, that is also true, right. So, if I substitute value, then 0, right, 0 minus V0 0 minus V 0 is nothing but minus IF by RF, because V I 1 is what 0 and here is V 0. So, 0 minus V 0 is nothing but IF RF. So, VO equals to minus IF RF minus I 1 RF, right. The trans resistance is nothing but delta VO by delta II is minus RF. Okay. So, now let us see this particular circuit. Now, I am not going to teach you what is trans conduction, trans resistance, right, that you have to understand how trans resistance can, how it is defined and how we have written delta VO by delta II, right. So, understand what is trans resistance, okay guys, understand something, try to learn by yourself as well. Okay. Now, VO equals to minus I 1 RF, correct. So, this is the value of output voltage given a circuit to you. Okay. Now, let us consider this particular circuit, which is our photodiode circuit. So, if you are given a photodiode, how can you measure the output? Okay. So, this is a photodiode, as you can see, and what is that? I 1 is 25 microampere per milliwatt of incident radiation. This much is the current that we can generate. Okay. So, at 50 millivolts, what is the power? What is the current? At 50 millivolts, it will be 50 into 25 into 10 raised to minus 6, because it is microampere, 1.25 milliampere. Now, if I assume that RF equals to 3.2 kilo ohm, then my output voltage VO would be minus 4 volts. Then my output voltage VO would be minus 4 volts. Alright. So, again, if I am given a photodiode circuit as shown in figure, and if I am told that I 1 equals to 25 microampere, that is the amount of current that the photodiode generates per milliwatt of incident radiation, and at 50 milliwatt what should be the final voltage? At 50 milliwatt what should be the final voltage? Then I had to use this formula, that I 1 equals to 50 into 25 into 10 raised to minus 6 will be 1.25 milliampere, and then I have to assume the value of RF. Assuming the value of RF to be close to 3.2, I will have output voltage equals to minus 4 volts, Okay. So, this is how your current to voltage converter works, and photodiode circuit is an example of current to voltage converter, and we have also seen how the differential amplifier works, right. So, this is all about this particular module. In the next module, let us see the application of an integrator, and then in another module we will see application of an differentiator. Again, you see I am breaking this module into small modules, or breaking this lecture into small modules, so that you can understand the concept, read it, solve few problems, get more problems and solve by yourself, alright, and also see what is the application of these amplifiers, alright. So, that is why the time I am squeezing down in 20, 25, 30, half an hour, whatever the lectures I can bring it to, whatever modules I can bring it to, so that you have enough time to understand and then digest and then solve more, and if you have any query you can ask, okay. If you have any query, feel free to ask. Okay. So, in the next module we will see the integrator. Till then you learn about this thing, understand what I have taught, right, understand how the current to voltage converter works, and solve few more examples by yourself, alright. Till then you take care, I will see you in the next module. Bye.